Good evening viewers. Today let us understand about class full addressing. So as we have discussed in the last class that IPv4 will have 32 bits of IP addressing. So in this as in class full addressing, classless addressing. Okay, in class full addressing, either of the IP address, anything will lie under only this 5 types of classes, class A, B, C, D, E. Okay, in classless addressing it will not fall under any of this class. So what are all this classful addressing we'll see and discuss in this class. Okay, so in classful addressing we can divide the IP address among any of these 5 classes, that is A, B, C, D, E. Okay, so in this one, if you can see here, so class A, this can be represented by the only if at all the first bit in the first byte it is 0, then it is nothing but class A. If it is in class B, first bit is 1, second bit is 0, class B. In class C, first bit is 1, second bit is 1, third bit is 0, then class C. If first 3 bits are 1 and fourth bit is 0, class D. If first 4 bits are 1, then it is class E. Right? So if I take 0 here, remaining will be 7 bits. 2 to the power of 7 will give 27 bits. So 0 to 127. So this is the range of class A. So when I come for class B, so here we have 2 digits already fixed, 1 0. Remaining will be of 6 bits. 2 to the power of 6 will give us 64. That is 127 plus 64 will give you 128. Sorry, 127 plus 64 will give you 191. Therefore, next 64 numbering range will be of class B. When I come for class C, here first 3 digits are already fixed, remaining will be 5, 2 to the power of 5 will be 32. That is when I add 191 plus 32, then I will get 223. So 192 to 223 lies under class C. So in class D, we have 4 bits already reserved. Next 4 bits, 2 to the power of 4 will be 16. For 223, if I add 16, then I will be getting 239. 224 to 239 will be the range of class D. Okay, so when I go for class E, again same thing here. If first 4 bits are ones, then it is class E. So after this 239 we have 240. So maximum we can have only 255 range in an 8 bit addressing. Therefore 240 to 255 is the range of class E. So these are the classes, different classes, how they can be identified. So here a flow chart is shown. You can see here, if we check first bit is 0, then it is class C. If first bit is 1 and if second bit is 0, then class V. First bit is 1, second bit is 1, third bit is 0, class C. First bit 1, second bit 1, third bit 1, fourth bit 0, and then class D. First bit, second bit, third bit, fourth bit, all of them are 1, class C. So there is a problem shown here to identify whether they are lying in classes. In this first one, we can check that first bit is 0. As we know that if first bit is 0, then it is solution, it is class A. So for a B here it is 110. As we know that 110 is a range fixed value for class C. Therefore it is class C IP addressing. For problem C, it is 14. 14 lies under 0 to 127. Therefore it is class A. Okay, so for D it is 255. 255 lies under the last value, that is 240 to 255. Therefore it falls under class C E. Like this we can identify the different IP classes. Okay, so let us see about what are the blocks in the IP classes. Okay, so here actually IP addresses we call them, you divide it into 2, that is in this one we also call it as network address and host address. So what are network address and host address? Let me show you. So you can see here we have assume that it is a college network. In this college network, assume we have 3 sub networks. Okay, this blue color is one network, this sky blue is another network, red is another network. So in each network we have many hosts connected. So this one network, we identify this network with this IP address 192.168.3.1. We identify this network with 192.168.1.1. We identify this network with 192.168.2.1. So each one have been given a different network address. So this one and this one is a network address. So in this network there are 1 2 3 devices. Again in this network there are 1 2 3 devices. So this 1 2 3 devices are the hosts of this network. Again this that is PC3 and PC2 and PC1, here they are the hosts of this network. So we have a network address and this is a host address. Okay, so in class A, as we have seen, the first bit 0 is reserved. Therefore we left out in class A, there will be first byte will be of network address and last byte will be of host address. We'll see it here again. So in this one, how many network address and host address will be there? So in this case here we have it is better to write down here. We'll be having 7 bits here, and here we have left out 24 bits. Let me reduce the size of the pen. Okay, in class B, here there are around if I subtract here 6 and from this it is 24. Okay, 16 minus 2 will be 14. 14 will be the network address. Okay, and we have here around 16 bits for host address. When I come for class C, here I will be having 24 minus 24 minus 3, that will be 21 and 8 2 to the power of 21 and 8. Here in class T there is no network address and host address concept. Okay, let me erase this and let me redraw this numbers. Let me zoom in. So here we have 2 to the power of 7, that is 127 networks, and remaining 3 bits will be of around 2 to the power of 24. That many hosts will be there. Okay, so when I come for here, that will be around 16,000 networks and 65k host. When I come for class C, there is a huge number, that is around 2 to the power of 21 networks, only 255 hosts. So here we don't have any concept of network and hosts. Okay, in class A, as we have seen, first byte will be of network address 0, so that is fixed here 0. Remaining 3 bytes will change 000. They can vary from 000 to 255. So that many hosts are possible. Again here network ID is 73, and here 73 is fixed, whereas 000 to 255 hosts can change. That is one of the example of this network address class A. So as we have seen, 127 network addresses are possible, around 16 crore hosts are possible. In class B, when I come for, that is 2 to the power of 14, 16,000 networks are possible, 2 to the power of 16 hosts are possible. Okay, so as you can see here in this one, net ID is 128.0. 2 bytes are used for network address representation, 2 bytes are used for host address representation. So 2 digits are fixed here as network address. So this only 2 digits vary, 00 to 255. They are the host connected in this network. You can see another diagram here. It is 180.8. This is a network address fixed. The host changed from 2 bytes last to around 255, right? So here it is a 128 and 180. It falls under second class, and up to 191 they can go up. So when I go for class C, so in class C, first 3 bytes are used for network addressing. Therefore you can see here first 3 bytes are network address, last byte is used for host addressing. Only 0 to 255 it can be varied. So it is 192. It varies from 192 to 223. Therefore last number is 223 is used. Either 200.11.8 is one more configuration used. 200.11.8 is one more configuration. Only last value is changing. Okay, you can see here 200.8.1 to 45, 55, 54. This is a range. Then whereas network address is 200.11.8.0. Okay. Similarly in class B here you can check here first 2 digit 180.8.0.0. Okay. Whereas the host connected to this network, they can vary from 01, 02, 79, 55, 54, 55, 55. So it starts from 00 to go up to this value. So this is one of the network, and that is described here. Okay. So if you want to see explain with class A, in class A also you can see the network address is 73, 3 bytes of hosts are there. So it came from 00 to 255. You can check here, it can be from 0733.0.0.1, can go up to 8.117. So this position can go up to 255. Again this can go up to 255. This can also go up to 255. Therefore last value will be 255, 255, 255. Okay, this is about the classes. Then finally if I go for class D, then then 4 digits are used for representing this class D. Out of 32, if I subtract 4, then I will have 28. So 2 to the power of 28 will give me a huge number. You can think that 268 crore IP addresses are possible, networks are possible in this one. These are used for multicasting purpose, but we don't require such huge number of IP addresses for multicasting. So in real time we cannot have a single group which will have 268 crore devices. It's not real time, so it's not of effective method. So if I go for class E again, the first 4 bits are 1111, and it is used for reserved for future applications, but that is again 2 to the power of 28 will give us around 268 crores. Again this many IP addresses are using it for reserving it for some special purpose is a waste of the IP addresses again. So the diagram here again shows a classes, IP classes. They are represented here. So the network address and host address are shown here. First bit is 0, 7 bits of network address, 24 bits of host address. In class B 2 bits are reserved, 2 to the power of 14 bits are network address, 16 bits are host address. In class C we have 3 bits reserved, 21 bits network address, 8 bits as host address. So in class D and E there are no host address, they are all network address. 2 to the power of 28. 2 to the power of 28 will be the number of networks possible. Okay. So there are some limitations of these addresses. So as we have in class A, only 127 networks are possible, and there are around a huge number of 2 to the power of 24 hosts are possible, which is in real time 4 billion devices, and we will never have such a huge number of devices within a single organization. Again it is a waste of an IP address. When I come for class B, in class B hosts are 2 to the power of 16. Again they are 65,000. It's in real time again we will not have such many devices within a network. hardly we may have 10,000 to 20,000 devices within a network. It's again a waste. When I come for class C, it is really good, and we have huge number of networks, 2 to the power of 21 networks, but the problem is with the host. The number of hosts in class C are only 256. So within a network, in a single network, just 256 devices is of meaningless. At least minimum we have 1000 devices in a network, right? So again, it's not a good practice actually. So even though we need to follow the same classes because they are all standardized. Okay, so here we are going to discuss about what is a network address and host address. Same thing is there. Here in class A, this first bytes are network address, remaining 3 bytes are host address. In class B, first 2 bytes are network address, last 2 bytes are host address. In class C, 3 bytes are network address, last byte is host address. Class D, we don't have, we use it for multi-class, we have only network address. In class C, again is used for reserved applications. Okay, so actually to find out a network address from a given IP address, we make use of masking. Okay, so mask will contain either a number of ones and only zeros. You can see here class A will have 8 bits, therefore this is a mask. Remaining host bits are 0. When I multiply any IP address with this mask, then I will be left out only this first 8 bits. That will give us only network address of class A. Similarly for class B, if I multiply this mask with class B, then I will get a 16 bits of network address. So when I multiply class C with this mask, then that is 24 bits ones, 8 bit zeros, then I will get a class C network address. So in dotted decimal they are represented as 255.000, 255.000 for class B, 3 255s, and last as 0 is class C. So in case of subnetting the representation, it is represented like this, that is /8. So in this indicates the first 8 bits are network address. Here /16, first 16 bits are network address, /24, first 16 bits are network address. Sorry, first 24 bits are network address. Okay. Then we'll discuss about subnetting and supernetting in the next class. Okay. So before that, I want to show you how this masking can be done. Okay. If I take a network here, so in this one you can see network address is 192.168.2.0. So how do we find out this one? Let me show you. Okay, in this one, if I take 192.168.2.100, so this is my network address, sorry, IP address of a device. Okay, for this IP address, when I multiply 255.255.255.0, okay, then I multiply this one with mask with this IP address, then I will get 192.168.2.0. okay, this whatever result I will get, this will be the network address here. This is the network address, you can see it's a same network address. Okay, so this is how the masking help us to find out the network address. Okay, thank you for your patience. Listen.